Okay, hello folks. This is the second lecture of week 12. After this, we have one more encounter with each other left, and that's going to be Friday at 10:30. So today I want to do at least part of a sample final. This is more to give you an idea of uh, what you should expect. However, uh, there's a caveat. First of all, let me show you the document that I emailed you. There are 4 questions equally weighted. And I already mentioned in my email that 3 of them are related to mechanisms, and one of them can be design table or parameterization, can be a part, or can be an assembly. Okay? Now, you're responsible for everything that we have done in the course. There is not a single item that I can say you don't have to know about it. Okay? After the midterm, right? Now, let's walk through this and see whether we can make sense of it. Problem number 1 here. Now, this is a problem from, I don't know, maybe a few years ago. And in that, on that test, on that final, I actually made these parts available. I actually made these parts available to the students so that they did not have to go through the process of making them. However, there is no such a thing this semester or this on this final. So you'll have to make the parse. You cannot download it. Okay. It's a problem that you're supposed to simulate. Okay. So here's the situation. You have to create this mechanism, and this ball, this wheel is going to roll down that ramp at a. Let me see now. At the the wheel is rolling on the track at a given constant angular velocity. Okay, constant angular velocity. Now, what happens is that when this thing moves, it pulls this let's say small arm up with it, and of course the big arm is going to turn. So basically, create a motion. Based on this information, I'm asking you to find a few things. First of all, uh, can you make this geometry? Yes, but that is not going to be the focus of this course. I know that you can make a box, or you can box with it, cut out like that, and this is not that course. Are the assembly constraints correct? In other words, whatever you did, you put it together to create the mechanism. I'm going to move them apart and then update. They should go back to where they belong. Okay? But again, this is just assembly constraints. Yes, these have part marks, but not substantial. I can tell you that upfront. Okay? Then I'm asking you to find the trace of a specific point. So there is a point here on the wheel. I'm asking you to create the point and display it in the assembly. In other words, bring it into the assembly. And you know how to do that? Okay? And convince me that you know how to say that the speed of the wheel is 30 RPM. Okay, in other words, the correct formula must be inputted. And then I'm asking you to plot a couple of things. First of all, the point A, this point A that I have a marker here, the magnitude of the velocity of this point A as a function of time. Okay, plot it. And then the magnitude of the velocity in terms of the magnitude of the acceleration of the point A. So these items 5 and 6, you have to create the plots. You have to screen capture, paste them in a Word document. One of them, give it this name, the other one, give it that name, and along with the rest of the stuff that you're going to be uploading, okay, upload these 2 plot Word documents to, or PDF if you convert them to PDF. Now, you're giving some information here. It says the units must be right. In other words, I want for example, when I say giving the magnitude of the linear velocity versus linear acceleration, the unit of this must be inch per second. This must be inch per second squared. Units must be right. And make sure you give us only one plot in that Word document. Don't give us something that has 3 plots on it, because then I'm not convinced that actually you know what you're asked to do, and therefore you decided to give me 10 plots, maybe one of them is going to be right. Okay. And the duration 2 seconds, of course. Now, I don't have the parts here, so I have to make this thing for you. I'll start doing this problem, and I will make this thing, and we do the rest of the problem. Are there any questions? Okay, there are no questions. Let's go ahead. I'm going to put this thing right in front of me in the other. Yeah, and by the way, down here, notice that it says this is a sample test. The motion is specified in terms of a simple single formula, basically. You should be able to write more complicated motion using the knowledge advisor. In other words, during the first 2 seconds, this is the velocity. During the next 3 seconds, this is the velocity, etc. So you wrote a program for it. You don't have to write a program for it. Okay, good. All right. Without any dimensions, because I'm going to create the mechanism. The rest of the stuff you have already seen and you should be able to do. I'm just going to create the mechanism for you. Okay, so let's start with the product file. Please, if you have issues doing the other ones, go watch the other video segments that we have done on mechanism. They're all there. Okay, so file, say management. The naming convention that you use for the final exam must be respected. So let me go up here. Okay, this is August 13, or I'll say new folder. I'm not going to follow that, but you have to. So this is going to be section 2. Section 2, problem 1. All right. So let me make the base first. The base means that track, basically that track. So insert a new part in there. Right click, properties, track, and track. Okay, let's make it. On that vertical plane, I will sketch. All right, something that is a rectangle, basically. Let's draw a rectangle here. Again, I'm not worried about any particular dimensions, although these dimensions do matter. Some of them matter because the information that I'm asking to generate does depend on certain dimensions. For example, the radius of that ball is important. Okay, radius of that wheel is important, but I'm not going to worry about it. Okay, so this is the exit. Okay, let me pad it. Let me make this thing 2. Okay, then I want a cutout here. Okay, so I'm going to make a track, and there are different ways of doing it. For example, one way is, let me see, what's the best way of doing this thing? Well, okay, so on this face, I will sketch a line like that. Okay, exit. On that face, I will sketch a rectangle. Okay, so a rectangle like that. I don't know how you're going to approach this, but this is how I'm going to do that, and exactly halfway. So this dimension, for example, I'm going to make it, there's a reason that I want to put exactly halfway. This is 1. Say OK. Exit. And then I can, I can pocket along that direction. So pocket. Let me see. Pocket. Maybe don't pocket. Let's do a different trick. Let me see now. How about slot? Where's the slot here? There. This profile along current curve. Let's do this. Okay. Good. Now, if that's bothering you, let's go and remove that top piece. The different ways of doing these things. This first sketch, this I'm going to make it longer. Exit. Very good. Okay, something like that. And the reason I made this thing exactly halfway in between, because the wheel, I want to give it the thickness of 1. Okay, so this whole thing is 2. The wheel, I'm going to make it thickness of 2. Now down here, we need a gadget for that crank. So on that face, we're going to make a little circle here. Exit. Pad it. All right. So that takes care of the wall, the track. Okay, so let's save everything. Let's insert the wheel next. So insert, new part, in there, wheel, right click, properties, wheel, and wheel. All right. Okay, so let's make it. So on a convenient plane, on that plane, I will sketch the circle. Okay, now I want this circle to be on that edge. The reason is that later on, when we do a roll curve joint, the curve is going to be that edge, and the thing that's going to roll on it must be on that edge. So I'm going to do it this way. There are, as I said, there are different ways of doing this thing. This curve, sketch, control that. Let's make a tangent. There. Okay, good. Now let's exit. Actually, let me make another circle in the center, because that's the shaft of this wheel. I'll do that later. Okay, so cancel. Otherwise, I have to do multipath. That's fine. So we go 1 inch. Now see, it's touching. Otherwise, you can't do the thing that you're planning to do. So on this face, I will sketch another circle. We make it concentric. This guy, control that guy. We make it concentric. It looks like I did a good job. Exit. And pad it. Okay. Something like that. And I need a marker here to see that actually this is turning. So on this face, once again, I'm going to draw a tiny little thing, just so that you can see that it's actually moving. Maybe make a pocket. Exit. Pocket. Yeah, that's good. Okay, good. That takes care of this. By the way, you have to create a point here. For example, you can take the center point of this circle if you want. On the test, when this was given, because I gave people the part, then there was a point already there. But for you, you go and create a point anywhere you want. In this case, for example, you can select the center. This is kind of left alone to you to do the rest of the problem if you want. Now, yeah, that's good. So let's go up here and save it. Then we're going to do the big arm. Okay, so big arm, so insert, new part, in there, no, right click. I don't know why I called it big arm, but anyway, all right, fine. Oh, big arm, properties, big arm. This is so that it's just consistent with the drawing that you have. Big arm. Okay, let's make it. Double click on it. All right, so on this plane, I will sketch. Well, to make it look something like what I have there, or something like this, as I said, because these were given to people, I didn't have to worry about it then. So exit, add it. I'll make it 0.5. Okay. We need a hole here. Actually, if you want a pathway, just like it is in the drawing. So at that end, I'm going to draw a rectangle and make a pocket there, just so that it looks like that. Reverse direction, all the way to last. Okay, what is it saying? Why is it not pocketing? Let's try it again. This all the way to, oh, I drew it on the wrong side. Okay, cancel. Let me see. No, it's okay. Should go all the way. Okay, so there. I don't know what I did first time. So over here, I'm going to make a circle, a hole, so that we can mount it on this end. Exit, pocket. Yep, all the way through. Good. All right. Now that's this, and then we're going to do the small arm. So we go up here, save, insert, new part, small arm. Okay, so right click properties, small arm, small arm. It's just another box basically. Let's make it. Yeah, so I'm going to use this thing to my advantage. On this face, I'm going to sketch. So I'm going to project these two. Project this edge and that edge. Okay. Okay, let's do this. Project. Yep. Project. Good. And we're going to close this because I want to pat it. exit. Okay, pad it. Let's make it a little bit more. If necessary, we can readjust the size. Yeah, okay. And on that face, I will sketch. Now, a circle that size, right? Let me show you something. This is not a big deal. You can draw a circle here and then make sure it's the same as that. But let me show you something here. So I'm going to project. I talked about these things before. See, you project this. The problem is that when you project it, it becomes yellow. You cannot move it. But what you can do is you can isolate this thing. Put the cursor there, right-click, and say isolate. When you isolate, this becomes white, and then you can just, where is it? You can move it. I did move some of it. Right there. As long as it was a projection, which was not isolated, you could not have moved it. Okay? Not a big deal. Go just draw a circle the right size. Exit and pocket. Good. This is it. I think this is it. All right. Let's go there. Save everything. And let's start doing the assembly. This is the stuff that you do in your 233 advanced, or I think it was 233, 230 advanced engineering design. There's nothing advanced about it. Just making a bunch of easy stuff. Okay. So let's anchor the track so that stays stationary. Let's mount this this guy on that. Okay, so coincidence between this axis and that axis. Okay, and coincidence between this plane and the back plane of this. That's going to become a revolute joint. Depending on how you do it, you may not actually need a revolute. You may only need cylindrical, but it all depends on how you go about doing the other joints. So this hide and show. Right. Okay. So the way I've done it, this is going to become a revolute joint. Now, this slides up and down this thing, so that's a prismatic joint. So coincidence between, for example, this face and that face, and coincidence between this edge and that edge. Okay? Good. The only thing is that I want it to be on the other side. Let's see if we can cheaply do this, fix this. So let me see for a second. Otherwise, I'll do it again. So yeah, unfortunately, I don't see. I should have done for this last one. I should have done this edge probably to that edge. I'm not sure. Let me delete this. Coincidence between this edge and that edge. Let's see how it works. Yeah, good. Okay. Now we're going to put this thing in that hole. Okay. Now I don't want this fellow to move. Okay, so for just temporarily, I'm going to attach this guy to the track because I don't want this thing to move. I want it to stay. As a matter of fact, why not? Because these have to be tangent to each other. I don't want it to move, but let's do it anyways. So coincidence between this axis and you have to put it on the curved surface right there. Okay, and let's say update, see what happens. Yeah, I see. I didn't want this thing to happen, but that's okay because I want to show you something. We have seen it, but we'll see it again. And then coincidence between this and well, yeah. Let me see now. What's the did it move? I was lucky. I want a coincidence between this and, where is that? I lost track of these things. So let's see now. And this happens. So let me move this thing in the X direction, see what happens. Okay, that's what it was. All right. Okay, good, good, good. Okay. Now, let me do the following. Let me cancel this. So right now, I want to create a revolute or a cylindrical between this and that. I think cylindrical will do, so we don't. Okay, fine. Now, let me rotate this rotate this whole thing about this axis. About this axis. Okay, and keep the constraints holding. Okay, now I want to bring this and put it on that surface so that these become tangent to each other. Okay, these two curves. So I use contact between this face and that face. And if it doesn't look the way I want it, internal and external, you change it. Update. That is not what I wanted. So double click on it and change it from internal to external. Update. There. Okay. All right. So well, let's check something here before we do the rest of this. Let me do another rotation about this. See actually if that stays in contact with that. I'm not sure. So let's see. Yeah, you see this? That's good. That's good. All right. Save everything. Now we're going to go to digital markup. Get the magic wand out. New mechanism. Okay. Auto create. Okay. And let's see. Probably the only one that is not done is that due to this contact. Roll curve. Roll curve is not done. Probably you have to do that. Check it out. So we have a prismatic, you know what it is. That's between this and this. We have a cylindrical between the big arm there, big arm, and the track. Now I wanted this thing to be revolute, okay? But that's okay. Just hang in there for a second. If necessary, we're going to change this. And this one, because all I did was to insert this hole in that shaft, then it's going to be cylindrical. Okay. All right. So let's check it out. Do a roll curve joint. There is a roll curve joint between this curve and that curve, and you say okay. Yeah. So that's because of this one came out to be cylindrical between the big arm. Wait a minute. Big arm, small arm. No, that's okay. Small arm and the wheel. I want this thing to be revolute. So let me delete this. Let me delete this. Delete it. Don't delete the children. And I'm going to manually create it. Okay. I can go to the assembly design and put the appropriate constraints so that it automatically converts into revolute. But I decided to manually do that, not go to the assembly design. So here's a revolute. Okay. Line. Okay, so let's see now. Line between this axis of this shaft, and I'm going to hide that, the axis of this hole, okay? And the planes. Now the planes, let me get these things back. Okay. The planes, you see, I don't have these planes touching each other. I don't have these planes touching each other, but that's okay. If they're touching each other, it's going to be null offset. So I can select this plane and that plane, which are not touching each other, but then I click on the offset. It says, I'm going to create a revolute joint, but there is an offset of 0.179 between them, which is great. I don't care. See, the degree of freedom is 1. Okay, and you can make this thing, I don't know, length driven. The roll curve, you can make it length driven. Of course, it's going to go to 0 when I do that. Mechanism can be simulated, and if it works manually, the rest of it is in the ball is in your court. You go and put the physics in it, and there we are. There we are. So the rest of it, putting the physics and getting the plots and things like that, of course, they carry their own part mark, and you've got to do it. Now, I'm not going to do that. Now, a couple of comments here, and that is this problem. If you go to my channel, you'll see this problem done there. I think this was 2000, I don't know, 17, 16, I don't know, something like that. But there is also a version that this arc, this is not a straight edge anymore. This is a circular edge, a circular arm, and this is another circular arm. So that is harder. That is also done. Okay? And if you want, you can go look at it. Okay, good. Any questions? Are you still alive? Oh, there's 31 of you. It must be 30. I'm the number 31. Okay, good. Yes, still alive. Great. That's good news. Thank you. All right, so let's go ahead and do the other one. So I'm going to get rid of this. Let me do the design table problem for you. What is this other one? This one. Okay, and the fine print, so that everybody's protected, is, hey, it says this is a sample test. It requires a design table for a part. You should also be able to do the other 3 variations, which means design table for an assembly, parameterizing a part, parameterizing an assembly. Okay, you should still be able to do that. All right. So the first thing I'm going to do is to create a nominal part which looks like that. I can use one of these dimensions. If it makes me feel better, I can use one of these dimensions. Okay. Otherwise, I can make my own dimensions. But why not we use it? So I'm going to go and make a part with this information. Okay. So let's go ahead there. Obviously, this is a part. So start with a part. If you do anything, if you start with an assembly and you can't finish the problem, that's going to be not good. So let's see. Now save this thing. File, save management, save as, up. Okay, this was section 2, problem 2, right? So make a new folder. Section 2. Problem 2. That will be problem 3. Problem 3. That's the design table problem for a part. Okay, don't worry about it. Problem 3. All right, let's go make it. So on this vertical plane, I will sketch. Basically, I have to draw something that looks like that. So you have to read the fine print. It says these, what does it say? It says these must have the same length. Okay, these have the same length. Okay, and these must be parallel. Okay, fine. Let's do it. Yep. So I'll draw something that for now, at least it looks like that. So I start here, then I go down, and then I go horizontally, and then I go up, and then I have to go kind of parallel to this, right? Parallel to this. Well, we'll clean it up, so I'll go with parallel. If not, we can make it parallel later on. And I'm going to stop there. Okay, good, good. And then we have to draw an arc of a circle here. I'll draw a quarter of a circle. The center of it is obviously on that thing, right? The center is right there. Okay. Let's do a quick trim, get rid of this. Okay, very good. And I'm going to project these things on the other side. Well, why don't we dimension the stuff that we want, by the way? So let's dimension the stuff that we want. So, well, actually, I need, yeah, let me project it. Now we can select, not project, I mean mirror it. That's what I mean. So you can select all of these. Control, right? Yeah, like this. How about that? Now the problem is that these axes are also selected. I don't want it. This guy, control that guy, control this, control that, and control this, and mirror it with respect to that fellow. Very good. Now, let's dimension the stuff that we have to control. So this is one of the dimensions. This is eventually going to be called D, right? And then this is going to be W. Eventually that's going to be W. Okay. And then the radius of the circle is going to be my R. Okay. And then the angle between these two is going to be alpha. The angle between these two is going to be alpha. So alpha, angle between this and that is going to be alpha. Now, you don't have to do it like that, but I'm gonna tell you what I have in mind, and that is, notice that it says this edge must be equal to that edge. Okay, this edge must be equal to that edge. So if this is W, this is also W. There's two ways to do that. One is to make this dimension this and say this dimension equal to that dimension. I'm not going to say it's equal to W, but I'm saying this dimension is equal to that dimension, and of course this is going to be W eventually. That's one way. Or you can dimension it and say this dimension that you make is equal to W. That's entirely up to you. But the point is that you need to dimension this. Okay. Yeah, save everything. Okay. Now let's go create our design table, the one that I gave you, namely this guy. Okay, exactly like it is. So I go to my Excel. Okay, so the first column is, I call it serial number. The second one is going to be material, my math. The third one is going to be alpha in degrees. Then it's going to be R in inches. And then it's going to be D in inches, little d in inches, and W in inches. Okay, let's put the numbers in there. So this is A001, A002, A003. Material, aluminum. I don't know, I always have a problem with aluminum. Is it aluminum or aluminium? So I'll make it brass. Because one of the British one is, and the American ones are different. So I don't know what it is in CATIA. So I'll just make gold. And Oh, I already had brass here. Okay, I'll make this thing brass and this one silver. I don't have a problem spelling silver. Silver, but it has to start with uppercase. Okay. Alpha, according to the table, 75, 120, and 45. Radius is 1.5, 0.5. That D side edge is 343, 343, and W 241, 241. By the way, I try not to give you stuff that is going to screw up your sketch, but it has happened in the past. So it could be that one of these was not thought of well, or I did not, do it ahead of time. Came out to be garbage when you try to screw up your sketch. I try to not to do it, and I hope that this is okay. I don't know. File, save as. Remember, you have to give us this Excel spreadsheet, otherwise you don't get any marks for that problem. Well, you get, I don't know, 1, 2 marks maybe for the part. I'm not sure, something like that. Where is that Excel? It was here, right? Yeah. Problem 2, problem 3. You put it in there. So we put it in there. Example 3, or problem 3 actually, not example. And you have to close this. Okay. Now let's exit. First of all, we have to pad this. And that you're told that the problem says right here that this is always 1 inch. So it's not one of your parameters. So just 1 inch. Not 0.787, 1 inch. Gotta read. Okay, let's apply a nominal material to that. Since I don't have to spell it, I can use aluminum. And remember, when it comes to design table for a part, I showed you one way of doing it. Now, there are other ways, and that is to rename for your own good, rename those dimensions. Okay, so you go to f of x, you click on part. I want this thing to be D. So I'm going to call this thing D. Okay. I want this thing to be R. So I'm going to call it R. I want that angle to be alpha. Okay. Now, the problem is that I want this thing also to be D, right? Not to be D, to be W. I want this thing to be W also. The problem is that the name W is taken already by something, and that was this, okay? So if I click on it, you see that? Oh, did I not take it? Oh, I'm sorry, this, I didn't do this thing. This thing, the formula equal to W. Oh, no, rename it. That's what I wanted to do. W, rename it, okay? Now, rename parameters are here. I want this guy also to be renamed, but I don't think it will take it because it says that, hey, I already have something called W here. Okay, so what I do is I say select this, say add a formula equal to that guy, which is W. But I don't think you could have renamed it. All right, what else do we have? Material. So you click on that. For the material and things, you have material and serial number. Remember, with design table, you have to do that manually, right? You have to do that manually, okay? We say okay. Hopefully there are no mistakes here. All right, now we go into the design table. We create it from an existing file, existing Excel file. It was this one. And this says, it says that, look, in your Excel file, if you have some names, and we do, there is a serial number, there is MECH, there is R, there is D and W. It says, if I see something in my database that has that same name, should I assume they're the same? The answer is yes. Now, you cannot do that the way we did the assembly today. We do not do it like this. Okay? So we say yes. What? Why did it not? Oh, you know what? Those renamings, I think I screwed up. Yeah. Cancel. Okay. Okay. So let's see. Something is screwed up here. The other things that I was okay. That's my equation. There's no problem. Design table. Let me see what happened here. I renamed some stuff. So how come it didn't see it in the? Let me see. Rename. Okay, there we are. These are the renamed one. Okay, very good. All right. That's okay. So why did it not alpha? What is this? I didn't have anything called beta. Did I have beta here? You know what? I may have taken the wrong Excel file. That's probably what happened. My guess, because I didn't have a beta here. So cancel. Let me delete this. Delete this. We don't have to do the equation. The equation is correct. So let's see now. Design table. Okay. Section 1. That was the wrong section. You're section 2. Right there. There. Oh, God. Ah, there we are. What it didn't see is the serial number and my math. So for serial number, you take part number, associate, and for my math, you take the material. Excuse me, material. Man, I was panicking, but for a good reason. You see how easy it is to screw it up. You go and look at the different spreadsheet. A001, double click. You guys are having this easy. Can you imagine trying to do these things in 2 hours, 2.5 hours in a lab? There we are. Material changed, serial number changed, and there we are. So we did 2 problems. The remaining 3, I'm going to do it for you for Friday. You may want to try that yourself and see where we're going. And I want to remind you of something here. No, I'm not going to show you the questions, but I want to show you something. Just think about it. Have a good Wednesday. See you on and Thursday, and see you on Friday to do the remaining 3 problems.